In today's video, I'm going to go through all the proofs by counterexample that have featured on previous Edexcel past papers. So if you're looking for a specific one, you can go to the time here or look at the timestamps below. This question from the Specimen paper was part B. In part A, you have to prove that this inequality was true for all positive x and y, but in this counterexample, you want to prove it's not true, necessarily, when x and y are both negative. The easiest thing we can do is to come up with just two random negative numbers. What I'm going to do is I'm going to come up with the smallest ones. We can take x equals, say, -1, and we can take y is equal to -2. You'll see that using negatives is quite a common trick in counterexample questions. For this one, it tells us to use negatives, so that's why I've just chosen two negatives, and we can just check it works. The root of xy on the left-hand side is the square root of 2, and the right-hand side, x plus y divided by 2 is going to be -1 plus -2. That's certainly negative because it's less than 0. So that means that -3 over 2 is going to be less than root 2, which means the inequality is not true. And therefore, that's a counterexample. From the 2018 paper, there's this big statement. If I add 3 to a number and square the sum, the result is greater than the square of the original number. And we have to prove if this is always true, sometimes true, or never true. It's worth 2 marks, so really without thinking about it, the answer is probably sometimes true, and you've got to find both situations. We're adding 3 to a number and then squaring it, so algebraically it's going to look like this, and we want to compare it to the square of the original, or n squared. Let's just try a number. For example, let's take n is equal to 1. Let's just see if it works. N plus 3 is going to be 4, which when we squared is going to be 16. And n squared is going to be 1 squared, which is 1. So the square of n plus 3 is bigger than the square of n. So maybe it's true, maybe it's always true. Going back to the idea of negatives though, what if we take n to be -3? This time, -3 plus 3 in the bracket is going to give 0, which when squared is still going to be 0. But -3 squared, n squared, is going to give 9. And now the inequality is not true, or it's backwards. Therefore, just as I suspected, the answer is that the statement is just sometimes true. If we skip forward 2 years, this question is another one that has the actual proof in part A. In part B, it's got a counterexample. This one doesn't say anything about negatives. It doesn't guide us, but let's try. It might work, it might not. When you're doing a proof by counterexample, you've got to try different types of numbers. So if a is -1 and b is -1, then 4a over b plus b over a, this time you might see that we're still going to get a positive number, which is still bigger than or equal to 4. But the idea in a counterexample is if something doesn't work, you try a different path. So I'm going to try one number as positive and one as negative, and we'll see if this works. A proof by counterexample only needs one singular example. If you find one example where it fails, that is your proof done. In this case, we get -5, which is definitely not bigger than or equal to 4. So this statement is not always true. For this next one, a student is investigating a statement because they clearly don't have anything better to do. They say n cubed minus n is a multiple of 4. Again, this is a part B, So the counterexample is just worth 1 mark. We just need to find one that doesn't work. In part A, you had to prove this statement was true for odd numbers. So in part B, it makes sense to try an even number. Let's just try n is equal to 2 and see what happens. If we do n cubed minus n, that'll be 2 cubed minus 2, which will be 8 minus 2, which will be 6. 6 isn't a multiple of 4, at least not the last time I checked. And therefore, this statement is not true. So n is equal to 2 is a counterexample. In this one, we are asked to show a disproof of if x squared is greater than 9, then x must be greater than 3. There are so many examples where this is true, but we're talking about a square number, so the answer is going to be something to do with a negative. So if we take, for example, minus 4, when we square this, we're going to get 16. That's greater than 9, which is great, but x, which is minus 4, is not greater than 3. That's because it's a negative number. Therefore, this statement is not true. Right, for the last one, we are given the statement q cubed minus p cubed is never a multiple of 5, and we want to show that it's not true using a counterexample. A multiple of 5 is always going to end in a 5 or a 0, and you might know that if you subtract 2 multiples of 5, the answer is still going to be a multiple of 5. So the most obvious thing to do is to take 2 multiples of 5, for example 10 and 5, just making sure q is bigger than p, to do the subtraction with the cubes and to see if it is a multiple of 5. So q cubed is 1000 and p cubed is 125. If we do the subtraction, q cubed minus p cubed, q cubed is quite hard to say, then we're going to get 875. And we know this is a multiple of 5 because it ends in a 5. So clearly this statement is false. Although I should probably say not true, just to match the wording of the question. If you've made it this far, then congratulations, here's a treat, 3 more questions for you.